Let's start with number 647, palindromic substrings. So in this question, we are given a string S and we have to return the number of palindromic substrings in it, right? So each individual alphabet will be a substring itself. Then we'll have to check if there's any other substring that is a palindrome here. So in this case, we have 6. Each individual letter is 1, and then we'll have to check for these two, and these 3, like that. So let's take a different example and see how we are going to do it. So in this case, we have a string ABBA, which is a event length string. And what we are going to do is we are going to check for two kinds of palindromes, an odd length palindrome and an even length palindrome. So why is that? Because for example, let's have this, right? It's a even length palindrome. So what we're going to do is we start with the center 2. BB is a palindrome, we expand outwards. This is a palindrome, right? This is for the whole string. But in this case, so what we do is we start from the middle element and then we expand outwards. But in this case, if we have only the odd or even case, we won't get all the necessary substrings, right? For example, if we do this, if we take the even case in this instance, so BB will be 1, ABBA will be 1. But the thing is, the answer will be all the other individual elements as well. So these are considered as odd. So we'll have to take in both odd and even elements. So let's see how we are going to do it. So during the start of a loop, we'll have a loop to check if they are palindromes, and a helper function which will take two indices based on if they are even or odd, will check if they're palindromes or not, and we'll have a overall count variable. So let's see. In the first iteration, for the odd ones, both of the indices are same, so a is 1, and will expand outwards until we are out of bounds. So this is out of bounds, and in the same iteration, for the even one, the string we have is AB, right? So in the next iteration, a single letter, we have an odd, so we add B, and then we expand outwards, we add ABB, and then it is out of bounds. In the same iteration, we have BB in the even case. If we move outwards, we have ABBA, which is also a palindrome, we add that, and then we are out of bounds. So in the third iteration, we have an odd case, we add B, and then it moves like that. It is not a palindrome, we'll keep it here as of now, and then R goes out of bounds. In the same iteration, the even one we have is BA, then it moves out of bounds. And in the last one, L and R are both at A, so we add that as the odd length, and then it is out of bounds for both the odd and even. So let's see how many palindromes we have. So it's 1, 2, 3, 4, 5, and 6. So the total palindromic strings or substrings we have is 6. So we'll define the initial count, and then we'll write the count palindrome function, which will take the indices and give us the count increase and also check if it is a palindrome or not. So we'll receive the left and the right indices, and then we'll have to check for palindrome. So what we can do is, so what we are checking is if it is 0 or more and lesser than the last character, and if all the characters we are checking are equal at the left and right positions. So what we'll do is, if it is equal, it's a palindrome, we'll increase the count, we'll expand, so we'll decrease the left pointer and increase the right pointer. This is our helper function. For our main function, we'll iterate through the string, and then we'll use our function. And as I said, for odd we'll have 1, for even we'll have 1. So for odd, the indices will be same, I, and even it will be I comma I plus 1, right? And then we'll return the count. Test case is accepted. Submit this.